Thanks, Alan. So we're all familiar with the potential electric cars have to help with climate change. Um, Especially the people selling these cars like to emphasize this. But something that is often forgotten is, or not mentioned, is that power isn't always clean. Across the US, we have a lot of coal-fired plants, like the one pictured, and they burn a lot of coal. In this case, it can burn upwards of 1,000 tons of coal every hour in its operation. This can result in massive greenhouse gas emissions. For example, although we only use 25% of our power comes from these coal-fired plants, they produce 50% of the emissions from power generation. So we really need to step away from these types of power. And we all know about solar panels, but their use in environments like deserts is questionable. So a good potential is concentrating solar, and that's what I am working on. The cool thing about my work is I'm electrical engineering, but I get to collaborate with a lot of other people, like in mechanical engineering, and I get to do what I do with optics. So that means I get to shoot lasers at stuff, which is great. So how does concentrating solar work? So it all starts with sunlight. So we have a sun there, and the rays of the sun are concentrated with mirrors to a tower. Some solar absorbing material collects this and turns it into heat. And it gets super hot, upwards of 800 degrees Celsius. We can then transfer this material down the tower and store it into storage containers. From there, we can create steam that runs steam generators and have on-demand electricity, whether it's sunny or cloudy, and power our cars. Of course, through this process, the material cools down so we can move it back up the tower and have the cycle restart. Ironically, before I had even heard of concentrating solar, I had encountered it. On a family road trip to California, we were driving through the Mojave Desert, and I had just woken up from a nap, dazed from the heat and the lack of AC in my parents' car, and I saw Sauron from Lord of the Rings. Well, in reality, it was concentrating solar, working, operational. And this is the picture that I actually took before my dad zoomed off. So fast forward 9 years, and here I am trying to solve the big issue with concentrating solar. What do we use as the absorbing material in these plants? So there's 3 major approaches. You can use liquids from molten salts, gases from supercritical gas, and solids with solid particles. Now, while the particles have okay thermal properties, they're cheap, simple designs, so we really need to improve their thermal properties to help concentrating solar become more mainstream. So here's a picture of the particles that I use, and I'm investigating, and if we take a closer look, we can see that these particles kind of stack and align in kind of random ways. And this causes little gaps between them. So if we try to put thermal energy in and take it out, this forms limited conductive pathways and limits the amount of energy and how fast we can take that energy out. But if we fill these gaps with smaller sized particles, that gives us more paths, and therefore we can take more energy out. Or at least that's the idea. So how do we incorporate lasers to test this? We can use a technique called modulated photothermal radiometry. This technique basically uses light to measure how heat moves through material. In the center, we have a furnace, which tries to simulate the conditions of CSP. And so we have our heated particles, and then we have a laser that is shot around the table and split. Some of it goes into a reference detector, and the rest is aimed at the particles. So we turn this laser on and off, and the frequency that we do that determines how far the heat travels through our samples. So we can kind of probe the different thermal characteristics through the depth, as we can see in this image here. The result of this is 2 signals, a reference signal from our detector and our infrared signal. And from these 2 signals, we can determine the thermal properties of our particles. while I still have a lot of work to do, based on what we're learning so far, concentrating solar has great potential, and you won't have to worry too much when you're charging your cars in the future. Thank you.